my name is Marian Gonzalez. We are Group 3. The project that we came up with, or the concept we came up with, was a satellite that we launch from Earth to space. And that satellite would be equipped with a laser that would shoot projectiles or space debris back into our Earth's orbit so it can burn up. That satellite will also be equipped with a nuclear reactor, because NASA also had like a really big problem with how they keep their satellites powered for a long duration. So a nuclear reactor would be a perfect way of doing it. Alright, this video is a visual representation of space debris, and in this video it's a old decommissioned Russian satellite that is abandoned. No one's operating it, it's just floating in space. And in another panel we have a brand new American satellite just got brought up to space. And briefly, if you haven't already could tell, this Russian satellite is about to collide with this American satellite. And in just a few seconds, you'll see that this satellite will collide and cause both of them to instantly get obliterated, causing thousands of pieces of more space debris to be in space, and boom, $1 million gone. So in the second part of the video, we have an old Chinese satellite. This satellite is also just like the other Russian one, where it's old, it's decommissioned. Its purpose is a weather satellite. And as you can see, there's a freaking ballistic missile going up to destroy it. China thought it was a good idea for their version of getting rid of space debris to blow it up. So boom, it blows up. Hundreds, if not thousands of more pieces are being projected into space, potentially causing a domino effect, which could potentially destroy even more satellites or any other shuttles or spaceships in the area. And there's another cutoff to... This is just another visual representation of like how much space trash is in our orbit. And basically, some scientists have said that, or researchers have said that in the next 50 years we can have our own, with the amount of trash in space, we can have our own ring like Saturn does with it's an asteroid belt, but with our trash. That's it.
So our satellite can push debris from a range of 5 millimeters to 10 millimeters into our atmosphere to burn up. Anything, we don't want to send any asteroids or anything that's close to an asteroid into the Earth to potentially cause damage. So obviously there's room for improvement, and that's the point. This idea can root for more ideas on dealing with space debris, because not only is it really hard to do because it's in space, but it's very expensive. So the whole money thing, you can't send stuff up in space without the money. So in order to be able to save some money and allow other companies and countries to successfully launch more satellites, rockets, or space stations, we need to get rid of space debris. So this is a good start to get rid of the small debris, because that small debris can, depending on the size, the small debris, depending on the size and how fast it's going, it can cause the same amount of damage as a small pebble can cause as much damage as, let's say, this cup, depending on the speed, and especially in space. So it's important to get rid of as much as we can, albeit let's start with the small, the 5 to 10 millimeters of space debris, and then later on someone can improve, or we can improve and make this idea into a better idea. That's the thing. Anyone can take our idea and improve it and turn it into something new, make it practical. But this is just the start, and that's the point. It's just the start.
So to basically wrap up what he was saying, we want to build a laser. We want a laser in space. We're building a space. I know what you're thinking. Group 3, how are you going to do this? Luckily, we don't got to do it. We just got to show a model and we got to put out a pitch. So, this is what we had to do it on. And this right here, I hate this. I hate this in my life. This sucks. It's not like Blender where you have full customization. Like, look at this guy. He's building a donut. He's doing a speed run right here. This is awesome. The way you navigate in Blender, amazing. I thought it was going to be the same thing. Oh boy, was I wrong. This sucks. You have to grab from these natural, basic shapes that like really just suck. You can't customize these in any way. You have no real creative flow. You have to spend multiple time. You have to spend multiple hours just doing everything you need to do for this one little piece. Like this piece right here, this took me about 2 hours to figure out how to navigate in here and build this little piece. I ended up not even using it. And look at this. What is this? The squiggle tool? This sucks. If you don't have any precision whatsoever, this just sucks. This is terrible. I hate this tool. Why does this exist? I know what you're all thinking. Oh, he took the easy way out. He didn't really want to do the project. He just want to put a box and some wings and like a radiator on it. No, I actually did build the satellite. I actually built the nuclear reactor part and the exhaust pipe. Look, this is 3 hours of footage condensed down into like a minute and a half right here. So this is my hard work right here. We got this. So this is the end result right here. We have our satellite right here. It's Team 3. This is where the laser comes out of. That's the exhaust port for like launching around. Right here is also exhaust, so they can get rotated around. These are their initial designs. I made them a lot more smaller, just so you can see what they originally looked like. And then inside right here are where the rods go inside of. As you can see right here, yeah, it's kind of wonky a little bit, but yeah. but you understand what I'm saying. Yeah, right here the rods go inside. They're going to be filled with uranium pellets that activate the reaction and whatnot. And yeah, so this is our final project. This right here is the heat shield for it. The heat shield in here. This is going to be the overall system inside right here. So yeah, that's our satellite right here.
Alright, so we're going to be talking about nuclear fusion, fission, So before we understand how our project works, we have to understand the history, what nuclear fission is, and how nuclear fission produces energy. The people who had discovered induced fusion were two men by the names of Niels Bohr and Ernest Rutherford in the 1910s. Both had worked on making a clear enough picture of the atom. A couple years later, after the neutron had been discovered by Enrico Fermi and James Chadwick in 1932, found that it would be a probe of the atomic nucleus. A year later, in 1933, Leo Szilard, a Hungarian physicist, had came up with the idea that fission, that is neutron-driven of heavy atoms, can create a nuclear chain reaction with energy generated by using protons. Physicists Otto Frisch and Lise Meitner in 1938 found that isotopes of barium appeared during their experiments, which was the result of the nuclei of uranium undergoing fission. Now we'll move on. What is nuclear fission? Before explaining how the laser works, I will explain what nuclear fission is. The nuclei is forced to absorb neutrons. This process has been utilized by societies around the world for nuclear power plants as well as nuclear weapons. The fission process can occur rapidly, but it is rare for that to occur. It can happen very slow or often as the chemical element. Fission is a certain kind of nuclear transmutation, which means that starting atoms aren't the same elements of the daughter product atom. Summed up, nuclear fission is the splitting of the atomic nuclei into smaller nuclei, which will release a large amount of energy. Nuclear fission can also aid the world in producing energy when chain reactions are controlled and reactive. On the other hand, if this process goes unsupervised, it can become a very powerful and destructive tool to utilize. An example of that would be the atom bomb. Both examples are reminders for the uses of fission. Now, the most important part, how does nuclear fission produce energy? This will relate to our project. A neutron first has to pass through a large atomic nucleus and is then captured by it. The amount of energy that is needed in order for fission to occur is 7 to 8 million MeV, or electron volts. When a nucleus that has that much energy hits the target nucleus, energy imparts and deforms the nucleus. Neutrons are released and hit 2 or more nuclei, which makes them split and release 4 neutrons. Those neutrons go on to be ejected and hit other nuclei. Because of the chain reaction that was caused by the nuclei splitting, it makes a doubling of fission reaction. The neutrons that were created are responsible for making a fission mechanism for generating energy, but it has to be controlled. That is important. Fun fact, the fission process is actually related to Einstein's discovery that both energy and mass are interchangeable, more well known as E equals mc squared. It is estimated that around 85% of the energy that is freed or released in the reaction from fission is released as kinetic energy. That energy is then converted into heat. The rest of the energy is redirected or transferred as kinetic energy to the released neutrons. The number of protons and neutrons will be preserved at its conclusion. The vital part is that neutrons are responsible for making fission an energy-generating mechanism that is viable. But remember, again, it has to be strictly controlled.
Hi, my name is Christopher Valdez. I'm going to talk about the launch of Sputnik 1 and space debris, which is space junk. The Soviets launched the first Sputnik satellite was one accomplishment in a string of technological success. Few in the United States have anticipated, even those who did were not aware of just how impressive it would be at 184 pounds. The Russian satellite was much heavier than anything the United States was developing at the time, and its successful launch was quickly followed by the launch of 2 additional satellites, which include the one that carried a dog into space. Together, these orbited the Earth every 90 minutes and created fear that the United States lagged far behind in technological capability. These concerns were compounded when the United States learned that the Soviet Union also tested the first intercontinental ballistic missiles. On October 4, 1957, the Soviet Union astonished the world by launching the Earth's first artificial satellite, Sputnik 1. This unexpected achievement set ripples of surprise to the United States, where have anticipated that their country would take the lead of scientific milestone. The success of Soviet launch sparked concerns that the United States was lagging behind the military technology development, fueling fears the state of the arms race and escalating tensions during the Cold War. The Sputnik launch changed everything. As a technical achievement, Sputnik caught the world's attention and the American public off guard. Its size was more impressive than Vanguard's intended 3.5 pounds payload. In addition of public fear that the Soviets' ability to launch satellites also translated into the fear of capability to launch ballistic missiles that could carry nuclear weapons from Europe to the US. The Soviets struck again. On November 3rd, Sputnik 2 was launched, carrying a much heavier payload including a dog named Leica. Now I'm going to talk about space debris. Space debris, also known as space junk, is made up of human objects in space that are no longer useful. It can include spacecraft, rocket parts, paint flecks, and more. Space debris can end up in space for more than a number of reasons. Most space junk is moving very fast and can reach a speed of 18,000 miles per hour, almost 7 times faster than a bullet. Due to the rate of speed and volume debris, current and future space bases, services, exploration and operations poses a safety risk to people and property in space on Earth. Collision and explosion can create large amounts of debris. For example, in 2009, a commercial satellite crashed into a Russian satellite at over 41,000 kilometers per hour. Satellites are no longer in use, may be brought down. Some items like rocket boosters may be left in space as a part of the plan. Space debris is a growing problem that poses a risk to spacecraft. Computer simulations suggest that debris larger than 8 inches will increase by 1.5 times over the 200 years, while smaller pieces will increase even more. However, an average of 200 to 400 tracked objects Earth atmosphere each year. A human population are rarely affected. Human populations live on a small percentage of an Earth's total surface area, so any objects that do not burn up and disintegrated upon atmospheric re-entry are likely to fall into the ocean, which covers 70% of the surface of the Earth, of a populated landed area. Space junk has been amassing since the first made satellite, Sputnik 1, escaped Earth's gravitational pull on October 4, 1957. The momentous event heralded the start of a space age as humans began to explore the further away from our homeland, a feat that has been repeated in more than 4,700 launches around the globe, but also means we've left our mark on space in the form of trash.
Alternative usage. Solar selling. Let's first go over how solar selling became an idea. The idea of solar selling originates from Johannes Kepler, when in 1608 he thought about using solar cells to power spaceflight. Johannes Kepler suggested that cells could be fashioned to glide through space by capturing sunlight, similar to how a boat sail catches the wind. However, the practical demonstration of solar cells was delayed until 1873. That's when James Clerk Maxwell proved that sunlight exerts pressure on reflective surfaces when photons bounce off them. Maxwell's theory of electromagnetic fields and radiation published between 1861 and 1864, established the theoretical foundation for solar selling. Solar cells make space exploration cheaper and more accessible. To propel a spacecraft, the cell is angled towards or away from the sun so that photons bounce off the reflective surface and push it. For example, a solar cell launched from Earth could tilt its cell to speed up and move into a higher orbit. It could even tilt in the opposite direction to slow down and move into a lower orbit. The Planetary Society and NASA have both been pioneers in solar cell technology. In 2005, the Planetary Society launched the Cosmos 1 solar cell spacecraft. It was launched from a submarine in the Bering Sea. Unfortunately, due to a rocket failure, it was prevented from reaching orbit. In 2019, NASA launched LightCell 2, a CubeSat the size of a loaf of bread that opened up solar panels and deployed a 32 square meter cell once it reached orbit. We'll now look at a video of how the LightCell 2 solar cell was created and launched. How our satellite will work with a solar cell. The way a solar cell moves is by receiving light. Within the light, there are particles called photons, which help create the momentum and push for the solar cell. The satellite will use the laser to strike the solar cell. As the solar cell gets struck by the laser, the solar cell will move in a much quicker and more efficient way.